Good day, kiddos, and welcome to Chem 20. Today we're going to learn about percent yield, and it's going to basically just using your knowledge of stoichiometry to help you decide, hey, this is what should have been produced, but how much was actually produced. So really quickly, we can use stoichiometry to test experimental designs. That's basically labs, technological skills, the purity of chemicals, etc. We evaluate these by calculating a percent yield. This is the ratio, this is where it becomes important, of the actual, another word for actual is experimental, quantity of a product obtained and the theoretical or predicted. Now the theoretical, use your stoich. You use your stoichiometry to find this, okay, to the predicted. Your actual is telling you what was, oops, actually produced. And that's usually from a lab, etc. And the formula is pretty simple. You just take your actual amount, you put it over your predicted amount, and that's, remember, from your stoich, and multiply it by 100 because we're talking about percent yield. The percentage of the yield that you should have, that you're comparing what you should have collected to what you actually collected. So here are some forms of experimental uncertainties. What experimental uncertainties means is error. What kind of errors could occur? All measurements are limited to the type of equipment you have. So any kind of measurement, any kind of measurement of mass, etc., etc. The purity of the chemical used. We know that chemicals, even when we order them, they're between 80 and 99.9% pure. Washing your precipitate. Did you wash it? Did you when you washed it out, did you make sure all of the water was, did you allow it to evaporate, that kind of thing? And estimation of the reaction completion. What that means is, did you allow the reaction enough time to fully react? Okay? Human error is not a thing. You can never ever say that, hey, human error is a source of error. This might be a question, just saying. So let's take a look at an example, because at the end of the day, kiddos, there isn't a lot of theory. The theory just is take a look at what you have, compare it to what you should have, okay? So here's an example. In a chemical analysis, 3 grams of silver nitrate in solution was reacted with excess sodium chromate, and it produced 2.81 grams of filtered dried precipitate. So this is what was produced. Okay, this is your actual, because it's telling you that it produced 2.81 grams of filtered dried precipitate. So what we have to do is we have to find the theoretical. So I need to find this. How much in theory was should have been actually produced? You start with populating your balanced equation. Of course, you have to start with balancing your equation. I have 3 grams, right, of silver nitrate, and this is your molar mass of silver nitrate. And then we want to know how the percent yield of the precipitate. This is your precipitate, kiddos. Why? Because it's solid here. You have to use your solubility table to figure it out. So then I'm looking for my mass. Since I'm looking for my mass, I use my molar mass. So now we recognize this. It's stoichiometry. I have 3 grams. I use my molar mass to get to moles. I use my ratio to go from what I know to what I am looking for. The 1 is for what I'm looking for, and the 2 comes from what I have of silver nitrate, right? And so in theory, I should, this is theoretical, in theory, if everything is perfect and everything's 100% pure, and you say you waited enough time for the reaction to be complete, I should get a mass of 2.93. I didn't. I actually collected 2.81. So what do? I just take my actual over my predicted, multiply by 100. This is what I actually produced. This is what I found using my stoichiometry to what I should have produced, I just divide those, multiply by 100, and I get a percent yield of 95.9, which is pretty darn good. So stoichiometry is used to predict the mass of precipitate actually produced in a reaction. We're predicting it. We're like, listen, this is what should be produced, and you compare that to what actually is produced. Filtration is used to separate the mass of the precipitate actually produced in a reaction. So when we form a precipitate by reacting this plus this, we're going to collect that using a filter, whatever, and then you're going to take what was actually produced and take the mass of it and then compare that to what was predicted. What mass, here's an example, what mass of lead, so we want to have the mass of lead, is produced by the reaction of 2.13 grams of zinc with an excess of lead to nitrate solution. So basically what we're doing here is we're just using an experiment to use our stoichiometry. So here's our predicted value. We have a balanced equation, and now we're going to populate the equation. We have 2.13 grams of zinc, and we want to find out the precipitate. So in this case here, we're not finding the precipitate, we're just finding the amount of lead. We need to find the amount of lead that was produced, and here's your molar mass of lead, okay? So with a stoichiometry, we're going to start with what we have, multiply it by the molar mass so that the grams cancel out. In this case, it's pretty easy. We're comparing these two. It's a 1-to-1 ratio, 1-to-1. And of course, we're using our molar mass so that the moles cancel out and you get your answer. So in theory, we should be able to, if I reacted 2.13 grams of zinc, I should be able to have a production of 6.75 grams of lead. Right, here's what we predicted. 6.75 grams of lead should be produced. But we have this data. We have our mass of our filter paper. And then we have the mass of the filter paper plus the lead. What I need to do is I need to subtract these two kiddos. I need to subtract these two in order to get the amount of lead, that was actually produced. Now, we can also find, if we can find the percent yield, which is the amount that was produced, we can actually find the percent difference. This is basically telling you the amount that was missed. So here's a formula that you use. Now this formula I don't like, but I'll show you an easy peasy way in the next slide of how to figure that out. So I take my experimental, subtracted by my predicted, divided by my predicted. Here's my experimental, here's my predicted, divided by, so experimental, subtract predicted, over predicted, and that gets you 1%. That tells you that I missed 1%. So that's a pretty good percent yield. Okay. So let's take a look at it from a different way. Prediction, 6.7 grams of lead should be actually produced. Here's my data. I have my mass of lead product, and I got that from subtracting the filter paper and the filter paper plus precipitate. Okay, so this is what I actually produced. I can find the percent yield. I take my 6.68, that's my actual, over predicted, times it by 100, I get 99%. Now, here's the easy way of looking at percent difference, the amount that was missed. Just take, here's my 100, that's funny. Take 100% minus 99%, and you get 1%. So you can use that fancy formula from the previous slide, or you can just say, hey, listen, if this was what if this is my percent yield, this is the amount that I collected, how much, what is the percent of the amount not collected? Well, it's the difference between the 99% and 100, which is 1%. So this is like the shortcut way of finding percent difference. And that's it, kiddos. Enjoy your day. I will post some questions, and I will see you later.